Hi everyone. I just want to sneak in one more quick example in this velocity and tangents section so that we've looked at something other than velocity as well. So this one isn't anything too crazy, but we have temperature readings. We've placed a potato in the oven and we've tracked the potato's temperature at various times. So we have time in minutes in the first column. So this is minutes. And we have temperature in degrees Fahrenheit in the second column. And we're going to calculate an average rate of change and make sure we think about exactly what that means. In fact, 15, oh, no, just one. And then we're going to do some estimates of instantaneous rates of change. Okay, so let's see, from t equals 15 to t equals 45, so we want average rate of change from t equals 15 to t equals 45. So looking back over here, we're going from 15 to 45. So we're going to take f of 45, 296, minus f of 180.5. And we're going to divide that by 45 minus 15. Okay, so the bottom is easy, 30, and then what are we getting here? We're getting 100, so 96, 106, 116, 115.5. Suddenly I don't trust my arithmetic, so I'm going to double check myself really quickly. 296 minus 180.5. Yeah, okay, got it. And we can make that an approximate. I'm going to go ahead and divide that by 30 if you want to see the exciting stuff going on. Here it is. So I get 3.85, and I actually don't even need the approximate there. Okay, so that's the average rate of change. We want to throw in units, and I want to make sure we talk about exactly what this is telling us. So what we did here was we took these out of the F column. So this was a change in temperature, change in temp, which is degrees Fahrenheit. And down here was a change in time, which is minutes in this problem. So this is going to be degrees Fahrenheit per minute. The units at the top of the fraction are degrees Fahrenheit. The units at the bottom of the fraction are minutes. So what this is telling us is that between 15-minute mark and the 45-minute mark, the temperature increased by 3.85 degrees Fahrenheit per minute on average. Again, if you actually look at this middle value, so let's say, okay, if it was going 3.85 degrees Fahrenheit per minute for 15 minutes, it should go up by 57.75. And if we add that to the 180.5 that we started with, this predicts that at 30 minutes, 15 minutes after our starting point, we should be at 238.25, and we're not. So this isn't perfect, but it's giving us a decent idea. It's a linear approximation of what's happening. Okay, so now we want to, estimate the temperature. Okay, so not another average rate of change. We now want to try and make an estimate of the temperature when t equals 46 and when t equals 50. So really what we're looking for is f of 46, but we're not expecting to get an exact answer. We're expecting to get an approximation of the answer. So this is really similar to what I was just looking at when t equals 46. So we know that when t equals 45, the temperature was 296 degrees. And right now, one of the estimates we have of how fast the temperature was increasing is this 3.85 degrees Fahrenheit per minute. It's only been 1 minute, so I expect it to be 3.85 degrees higher, approximately 3.85 degrees higher than before. So we're ending up with f of 46 is somewhere in the ballpark of almost 300, just shy of 300. So 299.85, okay. Degrees Fahrenheit. So there is a prediction. So this is one of the things you can use average velocities and average rates of change and instantaneous rates of change for, is making predictions based on this assumption that something is approximately linear. So we know they're not perfect, but if we don't get too crazy, we get decent estimates this way. Okay, so if we want to do this for 50 minutes, we just have to be a little careful. We could now say, okay, the closest piece of information I have is still this 296 degrees after 45 minutes. And now we want to know what's happening 5 minutes later. So I'm going to take this 3.85 degrees Fahrenheit per minute, and I'm going to multiply it by 5. So that's going to give me 5 minutes worth of increase. So 296 plus 3.85 times 5 is about 315.25 degrees Fahrenheit. All right, thanks for watching.